Okay, so we talked a little bit this morning about CSI and how it integrates Kubernetes into different storage environments. And we said we're going to have the CSI panel. So we have 3 of the developers of CSI on our panel today. Could you introduce yourselves?
Sure. My name is Luis Pabon, and I work for Portworx, and I've been working on Kubernetes since 1.3, and I've been working on CSI since 0.1, or before 0.1.
Well, I'm Jan Szafranek. I'm working for Red Hat, and I've been working for Kubernetes since 0 point something. I don't know, it's like 4 years. And I work on generic storage parts of Kubernetes, PVs, PVCs, dynamic provisioning, storage classes, and this kind of stuff.
Basically everything.
Yeah.
Oh, you got the mics. You don't need to.
Oh.
Okay.
Yeah. My name is Michelle. Can you hear me? Hello?
Turn on? Just turn on.
Okay. Hello?
Yeah.
All right. My name is Michelle. I'm an engineer at Google. I've been working on Kubernetes storage for about 2.5 years now, and I'm currently leading the CSI project in Kubernetes.
Doing a great job, too.
Brilliant. So let's start with a really easy question. What is CSI and why do we need it?
All right. What is CSI? First, we have to differentiate what CSI is and away from Kubernetes. CSI is a specification, and it stands for Container Storage Interface. And it was mainly created to make it simple to extend Kubernetes by adding a set of drivers that communicate with storage and let us manage it. So, you want to add anything else? Okay.
Oh, it's not Kubernetes specific.
That's right.
Interface. It's open. Initially in Kubernetes, we started with flex volumes. It was Kubernetes specific interface between Kubernetes and storage drivers, which turned out to be very inflexible. So we started with Flex 2.0, which turned out to be CSI in the end. And we opened for everybody, so not only Kubernetes, but also Mesos and Cloud Foundry and these guys can join and benefit from the storage drivers.
So CSI is I guess, container orchestrator agnostic. And it provides a standard interface for the orchestrators to talk to the storage systems. But perhaps, Michelle, could you tell us a little bit about how CSI works in Kubernetes?
Yeah, so basically drivers, storage vendors will write a CSI driver against the CSI API. And in Kubernetes, they end up getting deployed just like regular pods using daemon sets or deployments or stateful sets. So they're just like any other pod inside Kubernetes. So, and there's basically, drivers have 2 components to them, a node-specific component and a controller-specific component. The controller components handle all the control plane operations like creating and deleting volumes and attaching and detaching them. Whereas the node components will handle things like mounting and unmounting them. So there's various, for the controller drivers, we deploy a bunch of Kubernetes sidecars along with them. And these sidecars have the job of translating between the Kubernetes API to the CSI API.
Right. So CSI has been in development for a while. Would it be fair to say that CSI is ready for prime time? We're at sort of 1.0 now, but
I think that since Kubernetes, so actually let's step back a little bit. The CSI specification 1.0 has been out for a little while, and then 1.1. And that specification then has to be implemented. And that implementation, the first one is being done by Kubernetes. And Kubernetes 1.13 was able to use CSI version 1.0. So I'm going to start throwing out a bunch of numbers out here so don't get confused. So Kubernetes 1.13 is CSI 1.0 compatible. Kubernetes 1.14 is CSI 1.1 compatible, which is compatible with 1.0. Now 1.1 adds new features. Just want to make sure I answer the question correctly. What's the question?
Is it ready for prime time?
I believe that the more we start using it and we start developing it, the more stable and mature it will become. I believe that if we start using it with 1.13 and 1.14, we should start using it in production so that we start finding those edge cases that we can't find during testing. But I believe that it is ready for production.
And also to add, in 1.13 we have GA support for CSI 1.0, and so that not only means that from a CSI spec point of view, the CSI spec has to be backwards compatible to 1.0, but it also means that Kubernetes needs to also support backwards compatibility too. So now with 1.13 and 1.0, you can reliably upgrade drivers and upgrade Kubernetes without fear of breaking that CSI compatibility.
Brilliant. So, short answer, yes. Indeed. So, one of the things I think that maybe a lot of the people here might have questions about is there are probably, I don't know, 2,000 odd in3 drivers as well that people are still using, especially with maybe older versions of Kubernetes. But it's probably fair to say that just about every cloud provider and every storage provider has also built CSI, some sort of CSI integration at this stage. So now that we have CSI, what happens to the in3 drivers, and what is the process for migrating?
Okay, so Kubernetes has a strong compatibility promise. So if you have your cluster currently with in3 volume plugins and persistent volumes that uses these in3 volume plugins, the promise is that Kubernetes won't break it. So these objects will work, but inside Kubernetes 6 storage, we are working on migration. That means that we would like eventually to move all the storage code we have in Kubernetes to CSI, but without users noticing. That means that we will have some translation layer. If you use persistent volumes that use in3 volume plugins, we will translate them silently to CSI, and either users or cluster administrators should notice as little as possible. If they notice something, that we probably failed. That means we probably failed. So we are trying. This is currently alpha in Kubernetes 1.14. You can use Amazon EBS or GCE PD. In the future, we would like to extend the volume plugins to OpenStack, Azure, and whatnot. And it's still going to be alpha for some time, so it's a good time to test the Kubernetes, to test CSI drivers and report any errors. So we have this seamless translation bug-free when it's GA.
Bug-free?
Yeah, of course.
That's some promise.
Well, we would like to have.
You heard the first here, guys?
Yeah, exactly. It's recorded.
So, it's rare that we get kind of like the insight of working with some of the maintainers for such a crucial project. And the CSI project is kind of unique because it's building these bridges, right, between the Kubernetes on one side and different storage providers on the other side. So I was wondering if maybe you could give us a little bit of insight as to what the development process looks like and how you've built the community and interact with the different players.
Sorry, I missed the question. Maybe Luis can answer.
How do we do community development?
You are the leader.
Yeah, so we hold, as part of 6 Storage, we meet every 2 weeks and we plan features that we want to do as a community. And specifically for CSI, we have a special working group as a subset of 6 Storage where we specifically just focus on CSI-specific features, and we have stand-ups 3 times a week to basically, make sure we all have people code reviewing everything, or if there's any design blockers, we'll discuss them in our meetings. So if any of you are interested in getting involved, just join us at SIG Storage during our community meetings or our Slack channel, and we can help you, point you in the right directions.
Yeah. Absolutely. I'd like to add too that it has been quite a lot of work. I don't want to say that it was quite easy to add CSI support to Kubernetes. We've been working on this for a while. When we first started the project, we used to meet every day to see how the code was going and continuously developing. And what I would like to ask, actually, put this question to you, is that we need not only more participation from community members, but I would like to ask that CSI developers come to the meetings and let us know what your pluses and minuses are and things. You don't have to develop the code, just let us know what your experiences are, because we develop these systems, we develop these models with a certain criteria in mind and what we think we do. I mean, myself, I'm not only a contributor, but also I sound like a commercial. I'm not only a contributor, but I'm also a developer for our own driver. And, I have my opinions, but we need more opinions from other storage developers.
So that's fair. And I think most storage developers have a good driver to actually work with you guys.
Yeah, I thought it again. And what I find out is that we have so many storage systems, and I feel that as a community for storage systems, we are kind of disconnected. We kind of wait until something is created, and then we go ahead and develop it. And although that works sometimes, I'm asking you to come and share your experience often, because we're still in developing. This is still maturing.
So that's a brilliant segue. So why don't we talk a little bit about some of the features that are in development or maybe just recently released, and what's coming in the future?
Okay, yeah, so one thing I'd like to really point out that we've made a lot of improvements for storage vendors that are looking to write CSI drivers and get started. We have a Kubernetes-CSI documentation page, which documents all of our sidecars, and it has links to sample drivers to help get you started writing a new CSI driver. So that's a recent enhancement that we've done in the last few months to improve that documentation. In addition, we've also improved the Kubernetes end-to-end testing framework to make it easier to test your CSI drivers in Kubernetes. So before, what happened is that every driver that we supported had to be hard-coded in all of the tests. Now what you can do, we've sort of decoupled that. So now what you can do is you just download the binary, you write a simple configuration file for your driver, and then you run the binary against any Kubernetes driver with any CSI driver installed on it, and it runs the same tests that we test for all our in-tree drivers too.
Brilliant. And when it comes to features, so last time that we were on the panel in Seattle, we talked about features, for example, that were just coming out like snapshots. Yeah. Could we talk a little bit more about that and some other features which are coming out now, like perhaps resize?
Okay, I can talk a bit about snapshots. We had them as alpha in Kubernetes. You can take a snapshot of one volume and restore the snapshot as a new volume. But what we are working on right now is to have some group snapshots where you take snapshots of all your application. And it should take a consistent snapshot of all the volumes that the application uses. That's the goal. We are still getting there. Other features we are working on is resize. Currently we have something we call offline resize in Kubernetes. That means Kubernetes does all the resizing work except the resizing of the file system. where we expect that user must stop all the pods that use the volume, and then we resize the file system. What we want to get, where we want to get is online resize, where Kubernetes does all the everything, and the application doesn't notice and doesn't need to be restarted. What else are we working on? We are working on attach limits. That means that on storage backends that support only certain amount of volumes or certain capacity being attached to single node, we want a Kubernetes scheduler to be aware of these limits, so it doesn't put more pods or more volumes to single node that it can't handle. Are we working on? What else are we working on?
A few other things. Volume cloning. So this is the ability to create a new PVC from an existing PVC. And then what else are we doing? Windows is another area that we're investigating. So Windows containers went GA in Kubernetes in 1.14. However, CSI is not supported currently in Windows. So that's something to look forward to in the future as well.
And Jan, he just added also the leader election, right, for the sidecar containers.
Yeah.
So that way, before this change, it could have been that the provisioner could have gotten stuck, but now with this change, it will make it much more reliable. And again, this has to do with maturing of the services.
Brilliant. So some of these features obviously tie into some of the other topics we were talking about earlier around some of the day two operations. So things like snapshots to facilitate backups and volume resize, for example. There were some other features around that were announced in Kubernetes recently, like local volume support and raw block support. How are we looking to integrate that sort of functionality with CSI?
Do you know? Oh, that's not applying as well.
I guess, okay. Oh, I forgot. Yeah. One more new feature that we're working on is ephemeral volume support. So currently, you can only use CSI volumes using persistent volume claims. But with the ephemeral volumes feature, now you can use CSI volumes in line with pods. So when pods are created, the volume gets created, and when pods are destroyed, then the volume also gets destroyed. So this is good for a lot of local ephemeral use cases, such as loading secrets from third-party secret stores, and also having like data set caching of some,
In the raw block store, one of the interesting things is that block storage support was in the CSI spec since the beginning. And again, this is the difference between the specification being written and the implementation in Kubernetes side. But that is still, I think it's moving, it's still in alpha, right?
It's beta in 1.14.
In 1.14. So anyway, I think that feature is going to be quite interesting because it's going to allow for both databases to be installed and use raw block, but I also think that it's going to allow for some really nice, interesting situations where you can install storage systems themselves and consume block storage from something else. So anyway, I look forward to that also.
Brilliant. With that, I'd like to solicit any questions from the audience.
Just blow away.
Don't be shy.
Still shocked.
There's one over there.
I'm sure everybody's going to say that they want to start contributing immediately.
So, is there any plan to improve the user experience? I mean that we implemented a CSI server, and we have Kubernetes YAML files to deploy the CSI server. And it's very hard to explain to our users that why do we need so many site containers if Kubernetes supports the CSI natively.
Well, there is a long history why we don't do why Kubernetes doesn't talk to CSI drivers directly. The main reason is that hosted Kubernetes like GKE, AKS, and this kind of stuff doesn't really have an interface outside. You would need to run stuff on masters, and they don't allow you to run things on masters. I would dodge the questions because well, the user experience, for me, user is somebody who installs applications, like DevOps guy who comes and starts database and some front end in front of it. And these guys, they create PVCs as usual, they create pods as usual, they don't care about CSI. Yeah. The user experience for cluster admins, here I admit it is suboptimal. We are working on some way how to ease the installation, but unfortunately the number of external components is more likely to increase than to decrease. Yeah. Just the way to install them might be easier in the future.
Yeah, so one effort that we're starting to investigate now is if we can come up with common patterns or even like some sort of common operator that can work across CSI drivers that all have similar behaviors for upgrading and downgrading. So that's something that might help ease the deployment and management of a CSI driver. But it also depends very heavily on how different CSI drivers need to actually be operated and upgraded. But if you're writing a CSI driver and you want to participate in these discussions, please join us in SIG Storage and let us know, and we can include you in those.
And I also like to add that one of the things that we had to do when we started CSI development in Kubernetes is that we had to have the requirement where the CSI driver did not know it was installed in Kubernetes. So we had to create a kind of a bridge between a CSI driver and Kubernetes, and these bridges are what we call sidecar containers, and that's why they're everywhere. So because of that requirement, that's why the administrator sees that many sidecar containers. And there's also a sidecar container per node, and then there's some that manage provisioning and attaching. So that's the real reason why they're around. We have to really keep in mind that the CSI spec is not a Kubernetes spec. CSI spec is a CO agnostic specification, and the implementation of how we had to do it in Kubernetes so that the driver doesn't know it had to be rewritten just for Kubernetes is the implementation of these sidecar containers. Does that make sense? And again, I think at first is correctness. Correctness is first, and then after that we improve on it. But right now we are still trying to make sure that everything gets provisioned, everything gets mounted, everything gets attached, right?
So, quick segue into this sidecar container. So what's your opinion on Kubernetes distributions?
Not so bad.
If I had money, I would give it to you because it's exactly how I feel. All right, so we have a conversation, and again, this is just my opinion, but we are starting the conversation on when we first started the project, and we had to make sure that it was simple to extend Kubernetes, and so the sidecar containers are kind of the responsibility of the storage vendor. And again, we started this conversation not too long ago, so I don't want to skew it in any way. We still need to talk about it and decide as a community. But we have brought up the idea of, well, sidecar container management is quite expensive for storage vendors, which is hard enough to write the driver itself. Can we make it so that the CO manages that instead? So that's something to think about. We haven't decided that yet. It's kind of just, again, I had to write a paper on that to start the conversation. But I feel that's something we need to think about. So, do you have an opinion?
No.
It's currently open.
Yeah, exactly. But I completely understand.
Okay, and I think we're out of time now. So, one last question, Lisa?
I always say quick, and then
This doesn't have anything with CSI, but what you can do is to keep the old PVC around, but change the PV underneath. You can take a PVC and bind it to different PV. It is possible, and we sort of support it because everything what API server allows in Kubernetes is supported technically. So we support it, but we don't endorse it in any way. Be very, very careful.
So one thing that we are sort of looking in, and because this is definitely like backup and restore is a use case that we definitely want to support officially. So one effort that we are working with very closely with SIG apps is to develop a new like application snapshot or application backup objects and have actual, be able to have official backup flows supported through those objects. And that's something we're kind of co-designing right now with SIG apps.
Brilliant. So please all have a bit of applause for Luis, Jean, and Rochelle.
and thanks, Alex, for hosting that panel. Thank you.